So when people talk about Agile and they think, well, a lot of this is really common sense. Where did this possibly come from? And why is this something new? And why are we thinking about it? And why does this feel like it's got so many rules associated with it? It's important to realize where it came from and what it was in response to.
Software development has evolved through several different phases over the years. Very early on in the 40s and the 50s, computers were large and expensive, and programming was done by binary or machine code, which is tedious and error-prone. Additionally, the most common way to input data into a computer was through a punched card.
A typical punch card had 12 rows and 80 columns. It can be somewhat confusing to understand this when looking at the card. The 80 columns are clearly marked, as are the bottom 9 rows, which were the digit rows, numbered 1 through 9. There's 3 rows at the top to represent alphabetical and symbolic characters called the zone rows. Row 0 is visible, but above that, you have row 11 and finally row 12 towards the top, which are not represented in any way on the card. They appear blank, seemingly invisible. The corner was angled to keep a stack of cards in the correct orientation when fed into the machine. The most basic explanation is that the card is just an 80 by 12 array of bits. Bits being the most basic unit of information in computing. A hole punched equaled 1, not punched equaled 0. And it was up to the system that was reading the card to interpret them. Numbers and characters were represented by a combination of holes being punched in the zone rows and the digit rows. This was a type of encoding commonly referred to as Hollerith code, Hollerith being the original inventor of the punch card machine. Sound intuitive? It was at the time. The most popular systems were produced by IBM. In fact, it's not uncommon for these punch cards to be referred to as IBM punched cards.
And believe it or not, using punched cards was common all the way up until the 80s.
Eventually, we got high-level programming languages like Fortran and COBOL. A high-level programming language is easier for humans to read and write. It has syntax and commands that more closely resemble natural language, making it easier to express complex programming logic.
Lower-cost terminals allowed programmers to finally move away from the punched card input and use a more familiar keyboard.
It was amazing because now we had a terminal where we could see text, we could see the program, we could edit a file. So even in that short amount of time, it was elevated from punch cards to having what looks more modern today, a file and an editor, a text editor.
The 80s saw growing popularity of personal computers, and they supported very popular DOS or disk operating systems with even more accessible programming languages like BASIC. They also offered lower-cost magnetic disk storage, helping bring computing and programming to the general public.
The 1990s was the rise of the internet, which not only revolutionized communication, but nearly everything that touches our lives. Business, healthcare, education, society, really. And that's because developers were now creating web-based applications that could be accessed from any computer anywhere in the world.
A more efficient style of programming became popular that emphasized modular, reusable code that could be easily maintained and extended, called object-oriented programming, as well as the widespread use of open source software. Open source software encourages collaboration and sharing of knowledge, which leads to faster development and improvement of the software, which makes development cheaper and ultimately more flexible.
At the moment, we find ourselves having gone through the which just amplified everything that the internet offers because we always have it. It's in the palm of our hands. But now we're seeing emerging technologies like quantum computing, artificial intelligence like large language models popularized by ChatGPT, and there's the metaverse. All these technologies will bring in a new era of software development.
From the 50s to today, software development has evolved to become faster, more efficient, and more accessible. It touches and is a crucial part of nearly every industry.
But there was a problem. As technology moved forward, the process for managing software projects was seemingly stuck in the industrial age. As computers became more accessible, the need for more programs, more software also accelerated. But there was a problem around the philosophy of how to develop software. The reality was, as organizations started to move into the information age, most of their experience on how to build things came from the industrial age.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but
Efficiencies in the planning process were adopted.
In the world of manufacturing and construction, you would want a formalized approach that would allow you to have independent teams planning every major phase of the project, meaning you wouldn't start drawing plans for the building until the site work and foundation plans were complete. This would reduce the risk of errors or potential problems.
A similar approach was used for software development that was popularized in 1970 by Dr. Winston W. Royce. It was called downstream value of documentation. It's something we now call waterfall, or the waterfall methodology.
This waterfall approach became the standard software development process. It followed linear and sequential phases or stages and ensured each phase of the development process was completed before moving on to the next. The process typically follows 5 sequential stages. First was requirements gathering and analysis. This is often considered the most important phase as it sets the foundation for the entire project.
Here, the team would identify stakeholders, which may include customers, end users, business analysts, project managers, and developers. From there, they would define the scope of the project.
This involves identifying features, functionality, and the goals of the software. Next, they would gather requirements by conducting interviews, surveys, or workshops to collect information about the needs of the project and determine their feasibility and to identify any conflicts or inconsistencies.
Finally, the team would document the requirements in a very detailed and structured manner. This could involve creating use cases, functional specifications, or other documentation to ensure that all the stakeholders had a clear understanding of the project requirements.
Once the team was done with the requirements, they would move on to the design phase. They would base all this work on the results of the documentation from the first requirements phase. The design phase is typically divided into 2 subphases:
high-level design and detailed design. The high-level design phase would focus on things like system architecture, the comprehensive solution. And the detailed design phase would focus on the design of individual components of the system in great detail.
Now, the output of the design phase is more documentation. It provides a detailed design specification that serves as the blueprint for implementing the software solution.
So after all the work of the first 2 phases, which oftentimes would be months of work, you would end up with no working software, no minimal viable product.
Just a shelf of binders that contains detailed documentation of the project.
The third phase is the implementation phase, and this is where the coding would actually begin. The developers were careful to make sure that the work was based on the design and planning done in the previous two stages, but the work from the third phase would flow down to the fourth phase, which was testing. Once the tests were complete, the test team would create a report that summarizes the results. This report includes the number of tests run, the number of defects found, and the severity of each defect. Then, decisions have to be made to determine whether or not the defects could be fixed or would have to wait for the next version. At this point, the project would move into its final phase, which is deployment. Here, the team creates installation packages, end-user documentation, and other materials required to install and use the software. Then, the software would be deployed into a production environment where users would finally get access to the application. Each stage of the waterfall model has a specific goal, and the output of one stage becomes the input of the next. Once a stage is complete, it's difficult to go back and make changes, and remember, all this would take several months and even years.
The projects in the industry, they fail. Like maybe 80% of them are failing. Like why is that? And then they come to realize that because they have very heavy processes. Right? You have phases, right? So when you have phases like waterfall, right? You get the requirements, and then you do the design, and then you do the implementation, and then you do testing, and then you show the customer, and they say, "Hey, this is not what I wanted." But this is like 9 months later. This is why projects fail, because by the time you deliver something to the customer, the business situation already changed.
The waterfall model is useful for projects with well-defined and stable requirements, where changes are unlikely to occur. But it has faced significant criticism within the software development community. One of its most obvious drawbacks is its inherent inflexibility, making it difficult to accommodate the dynamic nature of the development process. It flat out fails to align with what software development is naturally good at: the ability to adapt, evolve, to be optimized, and extended.
It didn't work in software because software was much more iterative, it was much faster, and it could be delivered immediately. It wasn't as though it took 3 months to build something out of wood or to get the supply chain to deliver it. So they needed a new process on how to actually do this. Waterfall wasn't going to do it anymore, and Waterfall created a lot of barriers.
Recognizing these limitations, developers started looking for alternative approaches that would address these shortcomings and pave the way for a more efficient approach. Very early on, developers realized issues with the highly structured approach of Waterfall and began developing new systems and processes to move away from it. Agile didn't magically come together after one meeting at this ski resort. It was a process of pulling the best ideas from the various approaches developed over the years. There's several different approaches here, but I think we should spend some time looking at a few of them that trying to solve the problem of waterfall. And many of those people involved in creating these approaches were the ones who authored the Agile Manifesto.
Some ideas or approaches that were being worked on before Agile were things like the V model. It essentially extended the waterfall approach or waterfall methodology. It, too, supports the sequential and linear approach to software development, where each stage of the development cycle is completed before moving on to the next stage.
However, the V model differs from the waterfall model in that it emphasizes the importance of testing and quality assurance throughout the entire software development lifecycle, rather than just at the end of the development process. The V model also includes a feedback loop between each stage of the development lifecycle and the corresponding testing activities, which ultimately would ensure that any defects or bugs or issues that were caught could be addressed early on. So it was an improvement to the traditional waterfall approach. Again, it placed a greater emphasis on testing and quality assurance, but importantly, it was in each phase of the process instead of just at the end. Still, the V model wasn't the answer, so more approaches were developed. Rational Software, which later became part of IBM, created probably one of the most popular approaches at the time, called the Rational Unified Process, or RUP.
That was really what we were facing back then were large, still monolithic processes. Rational Unified RUP was common in the late 90s, maybe early 2000. It was very large, well-funded, lots of documentation, lots of marketing, Rational and I think later IBM.
In 2002, IBM purchased Rational Software to strengthen its software development capabilities and to offer end-to-end solutions to its customers that would help organizations improve the quality, efficiency, and reliability of their software development process. This solidified the Rational Unified Process as a legitimate and capable approach to software development.
They were what I would consider the 800-pound gorilla that we were fighting as smaller, lightweight, XP, feature-driven development, some of the other smaller methodologies that didn't have the marketing muscle. That's kind of what we were combating back in the late 90s.
The Rational Unified Process was a software development framework that was designed to be flexible and an adaptable approach to software development, allowing teams to tailor the process to their specific needs and project requirements. It included requirements gathering, analysis and design, implementation, testing, and deployment, much like waterfall, but it also emphasized the importance of iterative and incremental development, where the development process is broken down into smaller, more manageable stages or iterations. The Crystal method is based on the belief that not all projects are the same, and that project teams should be able to adapt and customize their approach based upon the specific needs of the project that they're working on. It's not a one-size-fits-all approach, but rather a set of principles and practices that can be customized to fit the needs of the project. It emphasizes the importance of human interactions and acknowledges that people and teams are at the core of successful software development. It differed from RUP by providing principles and guidelines versus a structured approach of different phases. Extreme Programming, or XP, was designed to improve software quality and responsiveness to changing customer requirements. XP emphasizes fast feedback, continuous testing, and continuous integration to enable frequent releases of working software. XP also includes a set of practices, such as test-driven development, which encourages developers to write automated tests before writing any code. This helps to ensure that the code is correct and that it meets the requirements. Other practices are also encouraged by XP, like paired programming, continuous integration, and refactoring. For our purposes, it's not important to be familiar with each of these practices, but rather understand that XP was trying to improve upon the limitations found within Waterfall. And you'll find Agile teams working today are still using many of the practices established by XP. There are, of course, others like adaptive software development, feature-driven development, pragmatic programming, but one of the most influential and successful is Scrum. It was developed in the mid-90s, and like XP, it's based on an iterative and incremental approach. It's like a rugby team. Everyone groups together in something called stand-ups, which is analogous to the scrum in rugby, before breaking apart to move the project towards the goal in something we call sprints. With sprints, teams work in short cycles called time boxes, and each sprint generally results in something being accomplished that contributes to a working piece of software. It's probably one of the most popular approaches today. All of this probably begs the question, how does Agile fit into any of this? If you look at each of these approaches, you'll find clues as to what Agile is all about.
The waterfall approach was cumbersome. It was a process where traditionally siloed teams that had little to do with one another were working in a phase process where each phase was treated as its own independent project, and each phase was completely dependent on the previous phase. The requirements team would document the requirements and hand that off to the design team. They would document the design of the software and then hand it off to the implementation team. And this would continue all the way down through testing, deployment, and sometimes maintenance phases.
If you think about it, each of these stages being so isolated is actually a problem when you have to adapt. We have a bunch of requirements that we gathered. We put them together and we said, okay, this is it. That's rigidity. You are creating a rigid set of rules right there and saying, this is what we need.
And that led to the gathering of a bunch of, 17 of us that had very different approaches. We kind of met, we left our egos at the door. We described to each other what our basic practices were like. As I remember, I think Martin Fowler had us do an exercise where we would write stuff down on an index card and kind of toss them on the floor. Then we looked at them. And we tried to come to an understanding of what's really important to software development.
The participants at the meeting here at Snowbird were already using or developing lightweight approaches that we talked about earlier, like Scrum, Extreme Programming, Crystal, and others. These philosophies, which later became known as Agile frameworks, share similar values and principles. By creating the Agile Manifesto, the participants aim to consolidate their ideas and provide a unified vision for these approaches, promoting a new mindset in the software development community. Many think of the manifesto as something that materialized out of 2 intense days of discussions here at a ski resort. But the meeting here was really the culmination of all the work of all the different approaches that were being developed from the mid-90s all the way through the early 2000s. In fact, the meeting here in Utah was the second meeting. The first happened a year earlier at the Rogue River Lodge in Oregon. That meeting wasn't about formalizing any one approach, but rather voicing support for all the approaches people were working on and that were attempting to break away from the traditional waterfall development model. But you have to remember, at the time, waterfall, complete with its heavy-handed approach, was normal for companies. It was the standard, the expectation. Developers could see the issues, but it was more difficult for organizations and their leaders to see them. The manifesto for Agile software development was seen to be somewhat extreme. But as time moved on, and as the development world evolved with the technological landscape, the extreme view seemed less extreme. So what is the manifesto exactly? First, the word manifesto can sound a little intimidating, but it really isn't. For example, the Agile Manifesto can fit on one page. It's simply a set of principles and values. And okay, values and principles sounds a little mushy, but here they're written in plain, non-technical language. And if you're wondering what's the difference between a value and a principle, well, the values come first. They lead to the principles. Values are that high-level belief. What do we believe is important in software development? The principles become the more practical approach of implementing those beliefs or values. Remember, these values are in non-technical, plain language. But what do they say exactly? Well, let's find out.
When people talk about Agile or its associated frameworks, you'll often hear the term value. And I'm not talking about the values of Agile, but rather the concept of what it means to deliver value to the customer. I asked the experts I interviewed, and here's how they responded.
Value, now that's a tough one, right? You may have to delete this. So value, what is a tough one, right? Basically, I don't know. That's why we have to deliver it early and see whether this is what the customers want. Value is how the customer perceives it. If they want it, that's value. You could deliver something that I think is valuable, right? But to the customer, it may not be valuable. So value is what the customers want, right? And we may not know what the customer want. We don't know what the customers want.
The idea that the customer is getting what they want. And the challenge is that they don't often know what they want at the very beginning of something. And so being able to deliver value and be able to deliver continuous work is what helps them uncover what the value is. And that journey may change over the course of a project.
Ooh, value. Okay, so value. The thing about value is it's in the eye of the beholder. So what we try and focus more is on business value, what provides value to the business. But for some businesses, getting a lot of things done provides value. For other businesses, delivering things that produce a profit or reduce cost is value. So it really comes down to listening and understanding what is considered value and then iterating and working toward delivering it as often as possible.
That's an important concept that everyone needs to understand. And when I work with like my colleague John Turley and I, we work with teams, and literally the first exercise is, so it's often joke, a little bit like Office Space, so what is it that you do here? But we actually try to have the team go through, what does value mean here? What's your purpose? And understanding value leads to the ability to make judgment decisions and maybe do less to get a higher amount of value for a given effort. Without understanding that, you can easily fall into the trap of, you're still delivering working software, but what if it's of lower value? What if it's just you're an order taker and you're not sort of negotiating the return on the investment to get the most bang for the buck, so to speak? It's not only important to deliver working software, it's important to make sure you understand that it's valuable. And that's from the client's perspective.
To define it in a simple definition, I would say value is the worth, benefit, or advantage that a product, feature, or service provides to its customers or end users. It's measured by how well it meets their needs, solves their problems, or improves their experience. Each of those characteristics could be tied to some monetary metric, but it's not required. As others have stated here, ultimately, your customer will determine the value of something for any given project.